Good day, students. Welcome to our lesson this week in General Mathematics. In this session, we're going to discuss present value of annuities. The formula to solve for the present value of ordinary annuity is P equals R times 1 minus 1 plus I over M raised to negative MT all over I over M, where P is the present value, R is the regular payments, I is the nominal interest rate, M is the compounding period, and T is the time in terms of years. So for example number 1, find the present value of an ordinary annuity with regular monthly payments worth 1,000 pesos at 3% annual interest rate compounded quarterly at the end of 4 years. How much is the interest? So obviously this is present value of an ordinary annuity. So the given R, or the regular payments, is 1,000. T is 4 years. I is 3% or 0.03. M is equal to 4 because compounded quarterly. So here we will be solving for the present value of an ordinary annuity. So we are going to use this formula. P equals R times 1 minus 1 plus I over M raised to negative MT all over I over M. So in our formulas, just substitute the values of R, T, I, and M. You're going to have P equals 1,000 times 1 minus 1 plus 0.03 all over 4 raised to negative 4 times 4 all over 0.03 over 4. So you're going to get 15,024.31. Meaning to say, the present value of this ordinary annuity is 15,024.31 pesos. Now, since the problem is also asking for the interest, we will use this formula to solve for interest. I equals RTM minus P. So take note that it is different from the formula to solve for the interest when we are talking about the future value. So since here present value is involved, the formula is different to solve for the interest. The formula for the interest is I equals RTM minus P. So just substitute the values of RTM as well as the obtained P. Now we have I equals 1,000 times 4 minus 15,024.31. This will be I equals 16,000 minus 15,024.31. Solve for the difference, so that's 975.69. This means that the interest amounted to 975 pesos 0.69 or 975.69 pesos or 975 pesos and 69 centavos. Now, we have a different formula for the present value of annuity-due. So the formula is much longer compared to the ordinary annuity. So P is equal to R times 1 plus I over M raised to 1 minus 1 plus I over M raised to negative MT all over I over M, where P is the present value, R is the regular payments, I is the nominal interest rate, M is the compounding period, and T is the time in terms of years. Example 2, find the present value of an annuity due with regular monthly payments worth 2,500 pesos at 6% interest rate compounded monthly at the end of 1.5 years. How much is the interest? So the given R is 2,500, T is 1.5 years, 6% or 0.06 is the nominal interest rate. M is 12. So we were going to solve for the present value. So we are going to use the formula P equals R times 1 plus I over M times 1 minus 1 plus I over M raised to negative MT over I over M, since this is annuity-due. So now solve for the present value of this annuity-due. Substitute the values of R, T, I, and M. So P equals 2,500 times 1 plus 0.06 over 12 times 1 minus 1 plus 0.06 over 12 raised to negative 12 times 1.5 all over 0.6 over 12. So here, 2,500 times 1 plus 0.06 over 12, that's 2,512.5. And then here, the items in the inside the bracket will result to approximately 17.17276,802. Multiplying it to 2,512.5, that's 43,146.58. So the present value of this annuity-due is equal to 43,146.58 pesos. So to solve for the interest, use the formula I equals RTM minus P. I equals 2,500 times 12 times 1.5 minus 43,146.58. So I equals 45,000 minus 43,146.58, and that's 100 or 1,853.42. So the interest amounted to 1,853.42 pesos. Example 3. A certain fund currently has 100,000 and is invested at 3% interest compounded annually. How much withdrawal can be made at the beginning of each year so that the fund will have zero balance at the end of 12 years? So here we will be solving for R, not for P, because the fund currently has 100,000. That's the present value. Okay? So the problem is asking for how much withdrawal can be made at the beginning of each year. So regular withdrawal. So that's R. So P is 100,000. T is 12 years. I is 3% or 0.03. M is equal to 1 because it is yearly. So let's solve for R. In this problem, so we will just manipulate the formula to solve for R. Our formula will be R equals P over 1 plus I over M times 1 minus 1 plus I over M raised to negative MT all over I over M. So just substitute the values of P, T, I, and M. You'll have this. R equals 100,000 over 1 plus 0.03 over 1 times 1 minus 1 plus 0.03 over 1 raised to negative 1 times 12 all over 0.03 over 1, and that will result to R equals 900 or 9,753.6. So the regular withdrawal must be 9,753.60 pesos. For the practice exercises, number 1, find the present value of the following. A. An ordinary annuity with 2,000 pesos regular payment at 3% compounded semi-annually for 3 years. Letter B, an ordinary annuity with 500 pesos regular payment at 2% compounded quarterly for 2 years. C, an annuity-due with 1,000 pesos regular payment at 3% compounded monthly for 4 years. Letter D, annuity-due of 2,000 pesos regular payment at 2% compounded quarterly for 5 years. So for A and B, you will be using the formula for the ordinary annuity. For C and D, you will be using the formula for the present value of an annuity-due. Number 2, in order to make equal withdrawals worth 5,000 pesos at the end of every month for the next 12 months, how much should be deposited into an account providing 2.7% interest rate compounded monthly? So, number 2 problem is the present value of ordinary annuity. Number 3, you buy a new computer worth 25,000 pesos today to pay at the end of every month for 2 years at 3% interest compounded monthly. How much are your monthly payments? How much total interest will you have to pay in 2 years? So in problem number 3, that's still present value of ordinary annuity, but in this case you must also solve for the interest. Good luck in solving these problems. Always remember, class, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy, and God bless everyone. See you next time for our next lesson.